All right, so today we're going to look at how to graph a quadratic inequality, and there's a few steps that you need to go through in order to complete this process. Step one is to graph the parabola's boundary. That's either going to be solid or dashed, dependent upon whether the inequality is equal to or not. Step two, once you have your parabola drawn in, you're going to test the point by choosing a point that's either inside or outside of the parabola. All right, make sure you test the point that is not actually on the boundary of the parabola. Step three, once you've tested that point, you're going to determine whether or not that point satisfied the original inequality. If it does, you're going to shade that region in. So you're basically going to be either testing a point inside or outside of the parabola, and depending upon whether it satisfied the inequality when you tested it, that's going to tell you whether you're shading inside the parabola or outside of the parabola. All right, so to solve a system of inequalities, we first need to remember what a system is. A system of inequalities is two or more inequalities that are working together. Now, the process to solve a system of inequalities is the exact same as what I just walked you guys through with those three steps. So step one, we're going to start with the first inequality. We'll graph it. We'll decide if it's going to have a solid or dashed boundary. We'll test a point to determine where we are shading. And then I'm going to do that exact same process for the second inequality. I'll graph the second inequality. I'll decide if that boundary is dotted or solid. I'll test a point to determine where to shade. Where those shadings of both inequalities overlap is going to be the solution set to both inequalities within that system. Let's take a look at a few examples. All right, in example one, we have y is greater than x minus 2 squared minus 3. And hopefully you recognize that this is a quadratic because the highest exponent is 2. And this is written in vertex form. So right off the bat, we can figure out the vertex without doing any work. And remember, if vertex form, we do the opposite of the inside. So opposite of negative 2 is 2. And then it's the same sign on the outside. So 2, negative 3. All right. I'm going to make a quick table to help figure out the rest of this parabola. I'm always going to put my vertex in the middle. And I'm going to pick a couple points to the left as well as to the right of the x value of 2. So to the left of 2 would be 1 and 0. To the right of 2 would be 3 and 4. And now I'll plug 0 in to this inequality for x. So 0 minus 2 is negative 2, squared is 4, 4 minus 3 is 1. Plug in 1, 1 minus 2 is negative 1, squared is 1, minus 3 is negative 2. And since a parabola is symmetric, these y values should match up. So we have 0, 1, 1, negative 2, 2, negative 3, 3, negative 2, 4, 1. And we got to decide what the boundary of this parabola is. Is it dotted or solid? Well, let's look at our original inequality. It's greater than. So remember, anytime it's greater than or less than, it's always going to be a dotted boundary. So I'm going to draw this as a dotted boundary for my parabola. All right, now my next step is to determine where I'm shading for this given inequality. I'm either going to test a point inside the parabola or outside of the parabola. So maybe I test a point that's outside the parabola. Let's choose something easy like 0, negative 5. And let's see if that works for our given inequality. So negative 5 is greater than 0 minus 2 squared minus 3. So we got negative 5 is greater than 0 minus 2 is negative 2, squared is 4, minus 3 is 1. Negative 5 is greater than 1. Nope, that's false. So we know that that's not part of my solution set. So the part that I'm going to shade is inside this parabola. All right, moving on to number 2. We have y is less than or equal to 2 times x minus 5 times x minus 1. So this is in factored form. Now, if you recall, if I set these factors equal to 0, these are going to be my solutions, my x-intercepts for this given quadratic inequality. So if I set x minus 5 equal to 0 and x minus 1 equal to 0, I get x equals 5, x equals 1. So I know that my x-intercepts are at 1 and 5. All right, now keep in mind that your vertex is in the middle of these two x-intercepts. So if I can find the middle of these 2 points, now if you forgot how to find the middle of 2 points, you add them up, divide by 2. So 5 plus 1 is 6. And divide that by 2, I get 3. So I know my vertex has to be at 3 something. Now to figure out the y value, let's plug 3 in. 3 minus 5 is negative 2, times it by the coefficient of 2 is negative 4. 3 minus 1 is 2. Negative 4 times 2 is negative 8. So 3, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, and then I could pick a few more points to help give a better indication as to what this parabola looks like. So maybe I pick a couple of points to the left of 3. Maybe I pick 2 and 1. And then a couple of points to the right of 3 would be 4 and 5. And then I would plug in those corresponding x values into the original inequality to find the y values. And if I do that, I would get 1, 0, 5, 0. Those were my x-intercepts. And then 2, negative 6, 4, negative 6. So let's go ahead and plot those other points. 2, negative 6, 1, 2, 3, 4, 5, 6, 4, negative 6. All right, now we got to figure out, is this a dotted or solid boundary line? Look at the original inequality. It's less than or equal to, so we know that's going to be solid. Let's draw that in. All right, and now we got to test a point. Remember, we're going to test a point either inside or outside of this parabola, but not can't test a point on the boundary. So let's test the point outside. Let's pick 0, 0. It's nice and easy to choose. So we got 0 is less than or equal to 2 times 0 minus 5 times 0 minus 1. We got 0 is less than or equal to 2 times negative 5 times negative 1. 0 is less than or equal to 10. Is that true or false? 0 is less than or equal to 10. That is true. So now I know that the point 0, 0 is part of my solution set. So that means everything outside of this parabola is part of my solution set. All right, moving on to number 3. We have another quadratic. Y is greater than or equal to negative 2x squared plus 16x minus 31. So notice this quadratic is written in standard form. Your leading coefficient is negative, so that should tell you that this parabola is going to open downward. All right, now since it's in standard form, we need to find our vertex, and to do that, we'll find our axis of symmetry by doing x equals opposite of b over 2a. So the opposite of 16 is negative 16 over 2 times a is negative 2. So we get negative 16 over negative 4, which is positive 4. So I know my vertex is at 4 comma something. So let's plug in to find, let's plug in 4 in for x to find the corresponding y value. So we got negative 2 times 4 squared, so that's 4 squared is 16 times negative 2 is negative 32. 16 times 4 is 64. 64 and negative 32 is 32 minus 31 is 1. So 4, 1 is my vertex. So let's go ahead and plot that. 1, 2, 3, 4, up 1. Pick a couple points to the left and right of my vertex. So maybe I pick 3 and 2, 5 and 6. And I need to plug in those corresponding x values back into the inequality to find the y values. And we would get 2, negative 7, which means 6 is also negative 7. Remember, it's equidistant, so they have the same, they're going to be symmetric. 3 is negative 1, 5 is negative 1. So let's plot those points. 2, negative 7, 1, 2, 3, 4, 5, 6, 7. 3, negative 1, 4, 1 we already plotted, 5, negative 1, and then 6, negative 7. figure out is this dotted or solid? Well, the inequality in the original statement is greater than or equal to, so that's solid. So we got a solid boundary line. Notice our parabola is going downwards. And we need to test the point. I like to test 0, 0 since it's not on the boundary. So we have 0 is greater than or equal to negative 2 times 0 squared plus 16 times 0 minus 31. 0 is greater than or equal to 0 plus 0 minus 31. 0 is greater than or equal to negative 31. That is true. So again, since that tested point satisfied the original inequality, it has to be part of my solution set. So I'm shading everything in that region, which in this case is outside of the parabola. All right, moving on to number 4, I see there's 2 inequalities in this problem. So here's our system of inequalities. So remember, the process is to graph each inequality individually, test a point, figure out where you're shading, and then where the shadings overlap, that's going to be our solution set to this given system of inequalities. So let's start with the top equation. We got y is less than or equal to negative 3 times x minus 2 squared plus 4. So notice it's in vertex form, which is convenient for us because I can find the vertex. It's the opposite of the inside. 2, same sign on the outside, 4. Pick a couple points to the left and right. So to the left of 2 is 0 and 1. To the right of 2 is 3 and 4. Let's plug in those x values to get our y values, and we get 0, negative 8, 1, 1, 3, 1, 4, negative 8. So let's go ahead and plot those points. 0, negative 8, 1, 2, 3, 4, 5, 6, 7, 8. 1, 1, 2, 4, 3, 1, 4, negative 8. And should this be a dotted or solid boundary? It is less than or equal to, so it's going to be solid. Test a point. Maybe I test 0, 0 again. All right, so let's plug 0 in for x and 0 in for y into that first inequality. 0 is less than negative or equal to negative 3 times 0 minus 2 squared plus 4. So we got 0 is less than or equal to negative 2 squared is 4 times negative 3 is negative 12 plus 4 is negative 8. So is 0 less than or equal to negative 8? That is false. So that means I must be shading inside this parabola. All right, now notice I didn't darken this shading in because I want to see where the overlaps are. So I'm just lightly shading right now. All right, next one. We got y is greater than or equal to 2 times x minus 5 times x minus 1. So again, these factors are going to be able to be set equal to 0, and I can find my x-intercepts. So we have 5, 0, 1, 2, 3, 4, 5, and 1, 0. And the vertex has to be in the middle of these 2 points. So if I add 5 and 1 together, that's 6. Divided by 2 is 3. And if I plug 3 in, 3 minus 5 is negative 2. Times the outside factor of 2 is negative 4. 3 minus 1 is 2. I get negative 8. Pick a couple points to the left and right. So we would get 1, 0, 2, negative 6, 3, negative 8, 4, negative 6, 5, 0. So we got 1 and 0 and 5 and 0 already plotted. Let's plot 2, negative 6, 2, 3, 4, 5, 6. And then 4, negative 6. And 3, negative 8. And this is also solid. Look at the inequality. It's equal to. Test a point. Maybe I test 2, 1. So we got 1 is greater than or equal to 2 times 2 minus 5 is negative 3. 2 minus 1 is 1. 1 has to be greater than or equal to negative 6. That is true. So I'm shading inside this parabola, and if you can see where the shadings overlap, those are going to be my solution set for this given system of inequalities, which would be where the red and the green shadings overlap, which is just this region right here in blue. So that would be my solution set.